Students, today in this session we will discuss the chemistry of Dizonium salts. Dizonium salts, they have the general formula C6H5 N2 positive Cl negative, commonly called benzene disonium chloride. They are written as C6H5, that is phenyl ring, N2 positive Cl negative. Students, as the name azonium means nitrogen must have positive charge. Salt means it is ionic. It is ionic species. But the plus charge is on the nitrogen atom that is bonded to benzene ring. You can write either in this form, either in this form, or either in this form. All are right. Benzene disonium chloride. Nitrogen atom that is in linked with ring, bonded with ring, it carry plus charge, and the second terminal nitrogen, it is neutral having one lone pair. And chloride, it is anion part. Benzene disonium chloride. Preparation of disonium salts. Students, disonium salts, they are prepared by treating an ice cold solution of aniline in hydrochloric acid with ice cold solution of nitrous acid. You already know nitrous acid is obtained by treating metal nitrite NaNO2 with HCl. When we undergo this reaction, what we got? Nitrous acid HNO2 plus NaCl. Under ice cold conditions, that is 273 to 278 Kelvin temperature. When we treat aniline in hydrochloric acid, when we mix aniline in hydrochloric acid with nitrous acid, we got disonium salt as the product. First, that's the reaction of container 1. Aniline undergo reaction with HCl under ice cold condition, form anilinium chloride. That's the reaction of second container. Already told you NaNO2 plus HCl will give HNO2 plus NaCl. Now when we mix these two containers, the overall reaction is anilinium chloride undergo reaction with nitrous acid. Anilinium chloride undergo reaction with nitrous acid under ice cold conditions. What will happen? Disonium salt is obtained plus water as byproduct. There are two oxygen atoms, means two water molecule. Friends, now add all these three equations. What will happen? It will cancel out. Anilinium chloride again cancel out. What is left? Aniline plus 2HCl plus NaNO2. Ice cold condition, what we got? Disonium salt plus NaCl plus 2 water. This chemical reaction is called diazotization reaction. That is the naming reaction important in your syllabus. Dizotization reaction. Reaction converting primary aromatic amines, aniline is primary aromatic amine, into disonium salt under ice cold conditions. It is mandatory to write ice cold condition. It is just the mechanism, detailed study, it is mechanism of this reaction. What is diazotization reaction? Direct you have to go for this equation. Diazotization, as the name indicates, in this reaction disonium salts are prepared by treating aniline with NaNO2 and HCl. Disonium salt is obtained. Metal will approach to non-metal, NaCl as byproduct. There are two oxygen atoms, two water molecules. Balance it, mention stoichiometry 2. It is called diazotization reaction. Reaction converting aniline into disonium salt, or you can say in this reaction disonium salt is obtained. Treating aniline with NaNO2 and HCl, that is reaction with nitrous acid HNO2. That's the mechanism, detailed study. Container 1, container 2. Then we mix up these under ice cold condition, we got disonium salt. Students, next there are some questions. First is why aliphatic disonium salt does not exist. We always mention phenyl ring in disonium group. Aliphatic disonium salts does not exist. They are highly unstable and decompose even at low temperature. Under ice cold condition they decompose, forming carbocation and stable N2 molecule. Students, at first disonium salts, they are unstable due to plus charge on nitrogen. What will happen in aliphatic disonium salt? Nitrogen withdraw electron, form stable nitrogen, leads to the formation of carbocation plus Cl negative. Why aliphatic disonium salt does not exist? They are highly unstable and decompose, form carbocation and stable N2. Now aromatic disonium salt, they are stable due to resonance. They are stable due to resonance, students. Aromatic compound, it is a unique property of aromatic compound, they undergo resonance. At first, you know Dysonium salts, they are unstable due to plus charge on Dysonium ion group. C6H5 N2 positive Cl negative. It is Dysonium chloride. Nitrogen that is bonded with ring carry plus charge and the second has lone pair neutral. It is anion part chloride. They are unstable due to Dysonium ion group. Students, in aromatic Dysonium salt, it undergo resonance. Nitrogen withdraw pi electron toward itself. That nitrogen of Dysonium ion withdraw electron from phenyl ring. That is second structure is obtained. When it got withdraw electron, definitely electron density increase negative charge and it withdraw electron from phenyl ring. The electron density at ortho position decrease, it has plus charge. This nitrogen which is in bond with benzene ring, it is stable student. So it is as such having plus charge on the first structure and plus charge in second structure. There are total 4 bonds around it in structure 1 and 4 in structure 2. After this what will happen? Now this pi electron shift to this position. Electron density at para decrease, plus charge at para. After this next, this shift to this position, electron density at ortho decrease. At last, withdraw electron. Lone pair again changes to bond pair. The last structure, that is second structure of benzene is obtained. Aromatic Dysonium salts, they are stable due to resonance. Start from this structure of Dysonium ion. Do resonance. Nitrogen withdraw pi electron toward itself and it withdraw electrons from phenyl. That is exocyclic double bond is formed. These are the 5 structures. It is clear students. There is dispersal of positive charge of nitrogen atom of Dysonium ion over the benzene ring due to resonance. Hence they are stable. Due to dispersal of positive charge of Dysonium ion group over ring due to resonance. After this, one more important note, that is specific note students. It is clear when we treat aniline with nitrous acid under ice cold condition. But we got Dysonium salt. It is called Dizotization reaction. It is called Dizotization reaction. But students, if we treat aniline with nitrous acid above 278 Kelvin temperature, under ice cold condition 273 to 278, it form Dysonium salt. But above 278 Kelvin temperature, the product is not Dysonium salt. The product is phenol students. Above 278 Kelvin temperature, it undergo reaction with nitrous acid. You know nitrous acid HNO2. Now this reaction proceeds. Bond break, phenol plus N2 plus water. It is important question in competitive exams. What is the major product? Which product is obtained upon treating aniline with nitrous acid above 278 Kelvin temperature? Definitely you will take phenol. That's the reaction of aniline with nitrous acid above 278 Kelvin. I told you the phenomena. C6H5OH plus N2 plus water. Aniline, nitrous acid under ice cold condition, Dysonium salt. Aniline, nitrous acid above 278 Kelvin. The product is not Dysonium salt. In this case, the product is phenol. After this, students, next chemical properties. In chemical properties, we will discuss chemical reactions. First one, reactions in which Dysonium ion group is completely removed. Dysonium ion group, it is replaced, that is nitrogen withdraw electron and form stable N2. This group is replaced. At first, replacement by OH group. When it is replaced by OH group, it is clear we got phenol. Friends, aqueous solution of Dysonium salt upon warming form phenol. What will happen when we treat Dysonium salt with water? Nitrogen withdraw electron. When it withdraw electron, it forms stable N2. Cl negative gain H ion from water, form HCl, and the left part, that is nucleophile, it will substitute this, strike at this, form phenol. It is nucleophilic substitution. It is substituted by negative part of attacking reagent. Again look here. These are the reactions in which Dysonium ion group is replaced. Nitrogen withdraw electron, form stable N2. Cl negative, it is anion part, definitely strike with positive part of the attacking reagent, form HCl. OH is left, that is we got phenol. Convert aniline to phenol. Aniline dizotization, Dysonium salt, then aqueous solution upon warming give phenol. Friends, when there are the conversions of aniline, 99% at first we will do dizotization and easily we can form what is the demand in the given equation. Second is substitution by ido group. When we treat diazonium salt with potassium iodide, it is clear diazonium ion group is replaced by negative part of attacking reagent, that is ido group, we got ido-benzene. Again clear students, N2 withdraw electron, form stable N2, Cl negative approach to K positive, form KCl, and it will replace form ido-benzene. Its assignment, convert aniline to ido-benzene. Do this assignment and submit on my number 94595 76600. Easy students. Convert aniline to ido-benzene. Aniline conversion 99%. At first write diazotization, it is, and in second step write Ki, you got ido-benzene. After this, next is substitution by fluoro group. Replacement by fluoro group. When this part is replaced by fluoro group, what we got? Fluorobenzene. That's the reaction students. We treat diazonium salt with fluoroboric acid, HBF4, it is called fluoroboric acid. Upon treating diazonium salt with fluoroboric acid, precipitate of benzene diazonium fluoroborate is obtained. It means what will happen? The reaction proceed. HCl eliminates as byproduct and results in the formation of precipitate of benzene diazonium fluoroborate. This decomposes upon heating. When we heat it, nitrogen withdraw electron N2 plus boron trifluoride as byproduct, and next left fluoride ion will substitute it, we got fluorobenzene. It is clear it is replaced by fluoro group, but it proceed in two steps. At first form precipitate of benzene diazonium fluoroborate. Then it decomposes upon heating, nitrogen withdraw electron N2 plus boron trifluoride, and rest left fluoride ion will replace it, we got fluorobenzene. Dear students, it is naming reaction, it is called as Walsh-Schiemann reaction. What is Walsh-Schiemann reaction? Reaction in which diazonium ion group is replaced by fluoro group. Or you can say in this reaction diazonium salt is converted into fluorobenzene, and do this chemical equation. Next is substitution by nitro group. Substitution by nitro group, that is when we treat diazonium salt with fluoroboric acid, that is the same step as we discussed. Precipitate of benzene diazonium fluoroborate is obtained. But in second step, we will heat it in the presence of sodium nitrite. When we simply heat it, we got fluorobenzene. When we heat it in the presence of sodium nitrite, NaNO2, the anion part is NO2, it will replace this, that is nitrogen withdraw electron N2 plus Na positive will approach to BF4 negative, form sodium fluoroborate NaBF4, and the major product is nitrobenzene. Convert aniline to nitrobenzene, you can easily proceed. Next is replacement by chloro, bromo or cyano groups. Students, these are the important reactions. These are the reactions of diazonium salt with cuprous salts. That is, we either use cuprous halide chloride or cuprous bromide in the presence of corresponding acid. Cuprous chloride, then we use HCl, cuprous bromide, then we use HBr. Friends, what will happen in these reactions? The anion part of the acid will replace diazonium ion group. In this, the anion part is Cl negative, we got chlorobenzene plus N2. Anion part is Br negative, we got bromobenzene plus N2. Again, it is pseudo halide cyanide. We substitute diazonium ion group with cyano group, that is treat diazonium salt with cuprous cyanide in the presence of KCN. It is clear in KCN nucleophile is Cn. We got cyanobenzene plus N2. Friends, this procedure using cuprous salt is called Sandmaeyer's reaction. It is important chemical reaction in chemistry, Sandmaeyer's reaction. What is Sandmaeyer's reaction? Reaction of diazonium salt with cuprous halide in the presence of corresponding acid. Cuprous salt we use cuprous chloride or cuprous bromide in HCl or HBr. Anion part will replace it. It is also Sandmaeyer's reaction. That is cuprous cyanide in KCN. After this, next is Gattermann's reaction. Gattermann's reaction, students, that is a modified form of Sandmaeyer's reaction. Gattermann's reaction, modified form of Sandmaeyer's reaction. Modified form means improved with little correction. थोड़ा सा इसमें correction किया गया. What is the correction? In Sandmaeyer's reaction we use cuprous halide, cuprous salt, but in Gattermann's reaction we use copper powder. If it is CuCl, in HCl we call it Sandmaeyer's reaction. Cuprous halide is replaced by copper powder, it is now Gattermann's reaction. Same reaction, students. Anion part will replace this, we got chlorobenzene plus N2. If we use CuBr in HBr, cuprous salt we use, it is sandmaeyer reaction. We got bromobenzene plus N2. If we use Cu in HBr, that is cuprous salt is replaced by copper powder, it is gattermann reaction. Again, if we use Cu oblique KCN, negative part is Cn, cyanobenzene plus N2. These all are gattermann reaction. Any one you have to show. If it is CuCl oblique HCl, sandmaeyer reaction, cuprous salt, sandmaeyer reaction, and copper powder, it is gattermann reaction. So I write it is the modified form of sandmaeyer reaction, improved with little correction. Now it is again assignment for you. Convert aniline to benzoic acid. If you understood, you can easily do. Aniline, diazotization, diazonium salt. We have to make benzoic acid. It means then try to make cyanobenzene. Go for this reaction. Either sandmaeyer or gattermann, CuCN oblique KCN or Cu oblique KCN. You got cyanobenzene, and you know cyanides on complete hydrolysis they give acids. Definitely benzoic acid is formed. I am sure you can easily do. After this, next is students, replacement by hydrogen atom. This is the reaction in which Dizonium ion group is replaced by hydrogen atom. Definitely the product is benzene. In this case the product is benzene, we also call it reduction. Addition of hydrogen is reduction. Substitution by hydrogen atom, that is reduction. Upon treating Dizonium salt with ethyl alcohol, students, benzene is formed. When we treat Dizonium salt with alcohol, reaction proceed due to Dizonium ion group. And in alcohol, the reaction proceed due to hydroxyl group as well as due to alpha carbon atom of alkyl group. That is, both will lose hydrogen. Reaction proceed due to hydroxyl group as well as due to alpha carbon atom of alkyl group, both will lose hydrogen. It means it is clear, when it loses one hydrogen, we eliminate one hydrogen from hydroxyl group and one hydrogen from alpha carbon. It will oxidize, what we got? CH3CHO. CH3CHO as byproduct. Now what will happen? It withdraw electron N2, one of the H strike to Cl form HCl, and second H it strike on phenyl ring form benzene. Benzene plus N2 plus HCl, and it oxidize to CH3CHO. There is a chemical reaction. Convert aniline to benzene. You will easily do. Aniline at first diazotization and then ethyl alcohol. This is also called deamination because we remove NH2 group from aniline. Aniline, diazotization, Dizonium salt, then ethyl alcohol, we got benzene. There is one more alternate way to proceed for this reaction, that is when we treat Dizonium salt with aqueous solution of hypophosphorus acid. Friends, phosphorus acid H3PO3. What is the basicity of this acid? 2. We have studied in P block. Phosphoric acid H3PO4, it is tribasic. What is hypo? Hypo means less oxygen. It is phosphorus acid, hypo H3PO2. Aqueous solution of hypophosphorus acid, it is reducing agent. You know reducing agent? Reduce the other, but itself is oxidized. It will gain oxygen and it will form H3PO3. H3PO3 as byproduct. What will happen? Nitrogen withdraw electron N2, Cl strike to H, form HCl. There are two hydrogen atoms in water. One will link with phenyl ring and form benzene. C6H6 plus N2 plus HCl. It will oxidize H3PO3. After this last, students, substitution by hydrogen sulfide group, SH group, thiophenol is obtained. C6H5OH is phenol, C6H5SH, it is thiophenol. Substitution by thio group, students, sulfur thio. When we treat Dizonium salt with potassium hydrogen sulfide, it is clear, nucleophile is SH, it will replace Dizonium ion group, C6H5SH, thiophenol plus KCl plus N2. These were the reactions in which Dizonium ion group is replaced. We study substitution by OH, substitution by Cl, substitution by CN group, substitution by hydrogen atom. After this second types of reaction, these are the reactions in which Dizonium ion group is retained. It is Dizonium ion group. It is unstable. Nitrogen has plus charge. It is retained. Means it will changes to its stable form in these reactions. Changes to in this form, students. Covalent form, stable form में replace हो जाएगा ये. And it is first reaction in your syllabus. It is coupling reaction. Again, most important. Sandmaeyer reaction, gattermann reaction, coupling reaction, dizotization reaction. These are important. Coupling reaction, students. This is the reaction of Dizonium salt. Dizotization reaction. That is preparation of diazonium salt. Coupling reaction, reaction of diazonium salt with electron-rich aromatic compounds like phenol or aniline, means with activating groups under ice cold conditions. Like dizotization, it is mandatory to write ice cold condition in this also. Students, coupling takes place at para position, and you know para position is 1 for opposite position. When we treat diazonium salt with phenol, what will happen? HCl eliminates as byproduct. That is, from para position hydrogen atom is replaced. Coupling कहाँ पे होगी? Para position पे. Always it takes place at para position. From para, hydrogen undergo reaction with Cl negative of diazonium chloride. HCl is eliminated as byproduct. What is left? C6H5N2. It strike on para position of benzene ring, and when it strike on para position of phenol, what will happen? It changes to its stable covalent form. C6H5 N2. It strike to the para position. Charge will not be there. It changes to its stable form. C6H5OH plus HCl. It is clear coupling takes place at para position. You can write N2 or you can write in this form. There is no charge. It is para hydroxyazobenzene. This chemical reaction is coupling reaction with either phenol or aniline. Same phenomena. Takes place at para position. From para, H is replaced, undergo reaction with chloride ion of diazonium chloride, HCl as byproduct, and it couples at para position. Leads to a formation of stable compound C6H5N2, that is para amino azobenzene. It is azo group, it is benzene, para amino azobenzene. You can do coupling reaction either in phenol or either in aniline. What is the difference? In phenols it takes place in weakly alkaline medium, and in aniline it takes place in weakly acidic medium. Role of pH. Coupling takes place at para position. Students, if para position is blocked, suppose I mention here a NO2 group. If para position is blocked, then coupling takes place at ortho position. Phenols are ortho and para directing. First preference to para. If para is blocked, then it will take place at ortho position. That is, hydrogen from ortho is replaced, undergo reaction with Cl negative of diazonium chloride, form HCl as byproduct, takes place at para position. If para is blocked, in this case para is blocked, students, what will happen? Now coupling takes place at ortho position. It will couple at ortho position of phenol. Clear? H is substituted, undergo reaction, N2, C6H5N2OH. But if both ortho and para positions are blocked, friends, it is picric acid, you know, trinitrophenol. All are blocked by any group, then coupling reaction will not take place. Go in detail. First, it at para position always. That is given to you. Coupling कहाँ पे होगी? Para पे होगी. But para is blocked, then coupling at ortho. If it is free, then para position C6H5N2, C6H4OH. Para is blocked, then at ortho position. If all ortho para are blocked, coupling reaction does not take place. That's all. Thank you.